Hi, welcome back to your new lesson. This is Lakshmi Kantiwari. In this video, I am going to show you what is the difference between big Endian and the little Endian. So before that, we have to understand the memory architecture of our microcontroller. The most of the memory are arranged into the 8-bit, that's mean the byte oriented. Let me draw a first memory architecture. So let's say here if you have a memory like this, and let's divide it into multiple the word oriented. So here you have a memory. Okay, so so here you have a memory. Okay, so this memory is 8-bit. okay, that's mean the each address of this memory is 8-bit, and if you divide this like this, then what you can get here, let's say you have it like this. In this way, you see from here to here it has a total 4 byte. That's the total 4 byte. Let's say the address starts from location the 00, okay, and then it goes to the another location, which you can say the 0x00, and then it goes 0x0001, and then the 0x0002, 0x0003, and then finally it goes here again 0x00 and the 4, and then finally you can say it goes to 000 and 5, and the so on. Okay, so the moreover the start of this address is 0x0000, and the start of this address is 000 and the 4, and the start of this address is 0x00 and 8. Okay, so once we have this, and the location, each location can store only the 8-bit of the data. Okay, that's mean 8-bit of the data. That means that should be the data that should be in between 0x00 to 0x00 to 0xFF. Okay, in decimal you can say from 00 to 255. This is the decimal number. Now the question comes here. Suppose that if you have a 32-bit of the data, let's say you have a 32-bit of the data, that means of the data. As in most of the ARM architecture, the data is a 32-bit if it is running into the ARM mode, and the instruction set is also a 32-bit, but in the thumb mode it is 16-bit. So let's consider it is 32-bit. Then how the data will be stored? The 32-bit can be classified into the 4 byte. Okay, so this is the upper byte, which starts from, let's say, the 31th location, 24-bit, and then here it has 23, and here it has 16, here it is a 15, start from the 8, and then it's 7. That's means 0 to 7, 8-bit, and here it has 8 to 15, 8-bit, the 16 to 23, 8-bit, and then finally 24 to 31, this is the 8-bit. That means what you can say, this is the most significant byte. So you can say this one is most significant byte. Remember, here I'm not talking about the bit, it's a byte, and here is the least significant byte. Okay, now the main problem comes here. The problem is, so this data, let's say this data is 1 byte data. Okay, so the 1 byte is the 8 bit, and this takes 1 memory location. So the question comes, the which byte should we store first? Let me make it with the byte 1, byte 2 and the byte 3. So let's say here you have a byte 0, here you have a byte 1, here you have a byte 2, and here you have a byte 3. So the byte 3 is the most significant. Now the question is, which byte we are going to store first? Okay, so there are the two ways to store this, and that two ways are like this. Let me delete first this one. The two way is like this. If I, let's say, make a copy of this address, the same address here, which starts from location 0x0000, and then this is the 1, 2 and 3. That's been the fourth byte, 0, 1, 2, 3. Okay, so there are the two way to store this. Either we can store here the byte 0 and then byte 1 and then byte 2 and then byte 3. And in a similar way, what we can do, we can store here byte 3 first, and then byte 2 and then byte 1 and then finally byte 0. So if you see here, the starting address is same for this data. Okay, so the data is same here. So let's say if I am going to store the data here 1 2 3 4 5 6 7 8. Okay, so the data is 1 2 3 4 5 6 and the 7 8. So here let's say these are the byte, and this is the byte 3, and let's say this is byte 2, and let's say this is the byte 1, and this is a byte 0. So in this case we can store the 78 here first, otherwise we can store here the 12 first. Okay, so we have option to store that values, that is the first here the 78, and in this case here we have stored 12. Now the main question comes here, which one is the big Endian and which one is the little Endian? Now this is the main question comes here. So what happens in a little Endian and the big Endian? So as we write, okay, as we write in a human readable format, so that is a kind of the big Endian. Okay, that's mean in the big Endian, what happened? In big Endian, that's mean the big end. Okay, in big Endian, that's mean this big end. Big end means the most significant byte. Most significant byte is stored first. Okay, so if you see here, the most significant byte is stored first here in this. Okay, in this architecture, that's mean here this is the big Endian. Okay, so this storing the data in this fashion is the big Endian. That's mean the most significant byte will be stored first. Okay, then it will be stored like this, 1 2 and then finally the 3 4 and then 5 6 and then finally 7 8. Okay, but in a little Endian, which is this one, in a little Endian, what happens? Little means this MSB, okay, LSB, this least significant byte. So this least significant byte is stored first, that's mean at the lowest address. So it first stores 78, and then it stores the 56, and then 34, and then finally it stores 12. So one thing you might here notice that from the lower address, if we go into the higher address, so this is kind of the human readable format, 1 2 3 4 5 6 7 8. Okay, so we write in this way in general. Okay, so the moreover, what we have made a point here that in a big Endian, the most significant byte is stored the first. That means at lowest address. Okay, but in little Endian, least significant byte, okay, is stored first. That means at lowest address. Okay, so once again I'm going to take here an example. Let's say you have a data in C programming, int a equal to some random number. I'm going to take 3 4 6 9 1 7 and 59. Okay, so here let's say we have here the byte. Okay, however this byte can be the maximum 255, but here I'm taking it into the decimal number, let's say. So this could be maximum 155. Okay, sorry, to 255 this data. Okay, this is not only limited to 3 4 or 99. So the question is here, if I ask you to store it into this memory location, then how would you store it? Okay, so let's say here if I ask you to store here into the little Endian and here into the big Endian. Okay, and the memory address starts from the 0x 003500, let's say. Okay, and here it also starts with the same location. The location is 0x003500. Okay, and this address will be 0x3501. it will be the 0x3502, and it will be the 0x350203, and similarly it will be the 0x3501, 0x3502, the 0x3503. Okay, so in a little Endian, if you see here, the least significant byte is stored first. That's mean at the lowest address. That's mean this is the LSB here. In a little Endian, that will be stored here first, and then it will be stored here the 17, then here the 69, and then here 34. But in the big Endian, the most significant byte will be stored first. That is the 34, and then the 69, and then 17, and then finally 59 will be stored there. So the question comes here, what is the advantage and the disadvantage of having little Endian and the big Endian? Okay, so let's say if you have a number, if I decrease these numbers to only, let's say, the 3 byte of number. Okay, so only the 3 byte of number, and let's represent that in the form of, let's say, a is equal to here let's take the same number, but we are not going to take this 3 4. Okay, now so the b, let's assign the b. Okay, so we are going to assign here the v is equal to 6917 and 59. Let's take this is the byte. Okay, so in this case, so this will be the MSB, that's the most significant byte, and this will be the LSB. So in this case, what will happen? In this case, I'm going to delete this first. So in this case, the MSB will be stored. That's the big here first. That's the 69, and then 17, and then 59. But here what happens? It first stores here the 59 and the 17 and 69. Okay, right, and this one is the empty. Okay, so we don't have anything here, so this is completely empty. The problem comes here. Let's say you had assigned int b equal to this number. Okay, but the later what you do in your code, you say no, I am going to assign now b is equal to a. Then what happens? B is modified with new number. Let's say this number is here 346917 and the 59. Okay, so let's say this is the new number here. Okay, so here you have a byte. In fact, you can say this is the 0x, and here this is the 0x. So this is all 0x. Let's represent it into the hexadecimal number to make it little more simpler. So here you have 0x b equal to 0x 346917 and 59. So what happens in this case here? Now 34 becomes MSB. Okay, so in a little Endian, you see you have already stored this 59 at the lowest place, and then the 17 at the second place, and then 69. And as per the definition of the little Endian, you need to store MSB at the highest address and the LSB at the lowest address. Then what we can do, we can simply add this 34 here at the highest location. That's the 0x34. But in this big Endian, as per the definition, big Endian says that the MSB should come at the lowest location. So in this case, what will happen? It will store here first 0x34, and then it will store 0x69, and then it will store 0x17, and then finally it will store 0x59. So if you might have noticed here is that it performs a shift operation. Okay, that is the shift operation. That means there is more read and the write. Okay, there is more read and the write. So this is the basic advantage and the disadvantage of having the little Endian and the big Endian. That means if there is the carry or a total number of bit change in the operation after the ALU in the variable, then in a big Endian there has to be a shift operation, but in the little Endian the processor or the ALU can simply store or add the data into the next byte. Okay, this is as simple as that. Okay, so the most of the RISC processors are based on the big Endian approach, and the Intel processors etc. are based on into a little Endian approach. Okay, however, the ARM processor have both option to be little Endian as well as a big Endian. So this is all about in this video. Please do not forget to subscribe this channel so that you can get updates directly into your inbox.